The second method for solving systems of equations algebraically is called elimination. The goal of elimination is to eliminate a variable when you add the two equations together. We've got a set of steps up here. Step 1, opposite match. Sometimes we already have an opposite match. Sometimes we have to create one. Step 2, eliminate. We add the two equations together, and either the x's or the y's are eliminated in the problem. Step 3, substitute. When we substitute, it's a lot like the substitution method. We've found a value for the variable, and we're substituting back in. We solve the equation once we've substituted that value in, and then we write the solution in ordered pair. These last 3 steps are exactly the same as the last 3 steps in a substitution problem. It's the beginning of this problem that's a different method than what we did in substitution. So let's take a look at an example. Step 1 is always to look for an opposite match. So as we look at this first 2, notice 2x and negative 2x are already an opposite match. So the two numbers match, but they have opposite signs. That lets us go straight to step 2, add the two equations together to eliminate a variable. Notice if you have 2x's and you take 2x's away, there are no more x's. But 3y plus 9y is 12y, and 11 plus 1 is 12. So now we can solve the little single variable equation that's here. We're going to divide both sides by 12 to get y alone, and y is equal to 1. From here on out, it's the same as if we had done this problem using the substitution method. We're going to take and substitute this 1 either here or there, wherever it looks simplest to you. Personally, I think the top one looks slightly simpler, so that's where I'm going to choose to go. 2x plus 3 times 1 equals 11 has been substituted, and now I can solve for x. This is 2x plus 3 equals 11. When I subtract 3 from each side, I have 2x equals 8. And to solve that equation, I'm going to divide both sides by 2 and see that x is equal to 4. So we're ready for the final step. Write the solution. Remember, the solution is the ordered pair of the point where these two lines meet. Well, these two lines meet at the point 4, 1. Let's take a look at the second problem. We're always looking for an opposite match, and notice this time we don't have one. 3x's is not the same thing as 1x. 6y's is not the same thing as 2y's. So we've got to find a way to make either the x's or the y's have the same number, but with the opposite sign. Now, how to do this varies from problem to problem, and sometimes there's more than one choice. So we sort of have 2 choices here. If I focus on the x's, notice I have 3 x's on top and just 1 x on the bottom. If we were to come in and multiply the bottom equation by a negative 3, we have to do it on both sides. Notice when we do that, we'll go from having just 1x to having negative 3x's, which is an opposite match with the 3x up above. So that makes that an option for how to start. Don't forget to distribute. We're going to have a plus 6y equals negative 24. I like to take that top equation and just rewrite it exactly as is below my equation so that I can see the two of them side by side. It makes it easier to go to the next step, which is to add the two equations together. Notice negative 3x plus 3x, those cancel out. But then notice in this problem, the 6y and the negative 6y also cancel out. So this entire side of the equation just equals 0. On the right-hand side of the equation, we end up with a negative 19, and we're like, wait a minute, that's very strange, because 0 is not equal to negative 19. When we get a false statement like this, it means there's no way for these two lines to ever meet. There's no way to make both equations true at the same time. So there is no solution to this system of equations, and all of our work is done for this particular problem. Let's take a look at the next one in this section. Again, we're looking for an opposite match, and again, we don't just automatically have one. So we take a look at this. I either need to make 4 and 7 match with opposite signs, or I need to make 2 and 3 match with opposite signs. Well, the 2 and the 3 already have opposite signs, so that's going to make it a little bit easier to make those match. But this is about as tricky as the problems get because I can't turn a 2 into 3 or 3 into 2. I've got to turn them both into something else. Well, notice if I multiply the top equation by 3, I got the 3 from right here. And I multiply the bottom equation by 2. I notice I got the 2 from right there. My top equation will become 12x plus 4y equals 42. And my bottom equation will become 14x. Sorry, that's not a plus 4y, that's a plus 6y. In my bottom equation, I'm going to have, let's see, 14x minus 6y equals negative 16. Notice right here in the middle, I've got my opposite match. My y's have the same number but opposite signs. So when I add the two equations together, I get 26x plus absolutely no y's. And then let's see, 42 minus 10 would be 32 minus 6 will be 26. So I have 26x equals 26. If we divide both sides by 26, x is equal to 1. So we're ready to substitute in. We can take this 1 and we can either put it here or here. They're kind of equal difficulty levels, so I'll just put it in the top because the numbers are slightly smaller. So I'm going to say 4 times 1 plus 2y equals 14. Well, that's 4 plus 2y equals 14. And if we subtract 4 from each side, we have 2y equals 10. Dividing both sides by 2, y is equal to 5. So now that we know both the x and the y, we can write our final answer. We can say that these two lines will meet at the point 1, 5.